So in today's lesson, we're going to talk about something called piecewise functions. So we'll be dealing with pieces of a function, not the entire function. So let's kind of go into detail on what exactly that is. So earlier today in class, we kind of just brainstormed as to what this graph meant, which this is an example of a piecewise function. We have pieces of a function, not entire functions, all displayed on one graph, which we talked about the weight of the mixed nuts and how much they would cost in price per pound. So now we're going to go into more detail on that after we discuss what piecewise functions are. So piecewise functions, again, we're not dealing with the entire function, only portions of the function. So it's a combination of one or more functions, and the function rules or graph differ on different intervals of x. So what that means, if we look at this graphically, we're going to only get parts of each function. So if you look at this graph, we have three different functions all displayed on one graph. And they're only displayed over certain intervals on our x-axis. So they kind of get chopped off where these dashed lines are. They don't get to continue on. Now, this is an example of what the function notation looks like, which this function notation does not have anything to do with this graph. I just wanted you to kind of see what each look like. But again, we'll have different functions, and they will only occur on certain intervals on the x-axis. Just like over here, these graphs only occurred on certain intervals of our x-axis. So let's dive into that mixed nut problem that we were talking about, and we're going to go into more detail on how to actually solve using these graphs. So this is going to be your example 1. Okay, so you need to go ahead and get out your handy dandy notebook and start copying down this problem. So I will be doing example 1 on the Prezi, not on a separate video. So in this graph, we did talk about what this graph meant and what the different intervals mean, but now we're going to go into more specifics on what those values mean. So the weight per pound on our graph is located on the x-axis, so these will be our x values in our table. And the y-axis talks about the price per pound, so how much the nuts will cost per pound. So the higher in weight they go, it'll tell you how much they cost. So let's talk about these y values. The y values will be how much each different category will cost in terms of price per pound. So our first section that we'll be looking at right here, okay, this is our very first section. Okay, in the very first section, let's take a look at our x values. So when we look at piecewise function graphs, we're going to have closed bubbles and open bubbles. So what these mean, if you ever see an open bubble, that means the graph cannot equal that value. Values on a graph are only equal to something if it's actually shaded on the graph. So open bubbles means the graph does not equal that value. If it is a closed bubble, it means the graph can equal that value. And these closed and open bubbles represent our intervals for each different section for each different function. So on our first section of our graph, the x values go from 0 to 1.99. And technically, you could say 1.99999. Now, let's talk about why it does not equal 2. So if we look at our first interval, the reason why it doesn't equal 2 is this first section has an open bubble sitting on 2 on the x-axis. So that means it cannot equal 2. So it gets really close to 2, but it never touches it. So those are the x values for that section. Now the y values, let's take a look. Where this interval hits the y-axis is at 8, right here. So our y value will be at 8. Okay, and then our verbal description, so describe what we just talked about. When the weight is, I said under 2 pounds. Now you could say this differently. You could say between 0 and 1.99 or however you want. I chose to say under 2 pounds. Okay, when the weight of your mixed nuts are under 2 pounds, the price is $8. Now let's talk about our next function, which is this middle function right here. Okay, our next interval is between these two dashed lines, between the blue and the purple dashed lines. So this interval occurs from 2 all the way to 4.99. Now the reason why I said 2, this one, it can equal 2 because there is a closed bubble right there. Okay, so on 2, this one can equal it because there is a closed bubble. Now the reason why we can't equal 5, which this is 5, it's in between 4 and 6, is because there's an open bubble on this function. So we're only looking at this middle function right now. Okay, so we start at 2 and go all the way out to 4.99. And the y values that are associated with this section is at 6. So the y values from 2 to 4.99 is at 6. And the verbal description of this is when the weight is in between 2 pounds and 4.99, or however you would like to say that. The price is going to be $6. And finally, our last section of this piecewise graph is this third and final graph, kind of the one that's farthest to the right. Now, this one's a little different. So on this one, I'm going to say this section is from 5 and up. Now, the reason why we say 5 and up is because we got an arrow on this end. So it starts at 5, which it can equal 5 because there's a closed bubble right there at the 5. Now, we have this arrow, which means it continues on to infinity and beyond with Buzz Lightyear. If you didn't know, Buzz Lightyear does hang out at infinity, which is really awesome. But anyways, we're going to be extending to infinity in the positive direction. So we're going to say 5 and up. So our interval on the x is from 5 all the way out to infinity, or everything above 5 in this case. And the y value associated with this, if we go back to our y-axis, it falls right in between 4 and 6. So the y value in our third section is at $5. So this we could say when the weight is 5 pounds and up, or over, or 5 pounds and over, or however you want to say that, the price is $5. Okay, now we're going to take this problem a step further. So my next slide still goes with example 1, but this time it's about to get fun, you guys. We're going to represent all of this information in our table using function notation. So let's get ready. Alright, so this right here. In our last section we dealt with function notation, but only with one function at a time. But since we have 3 different functions on this graph, we're going to have 3 different functions in our piecewise function notation. So get pumped up. Alright, so whenever you use function notation using a piecewise function, the very first thing we put in our piecewise function are the y values. Now the reason why we have this curly brace, since piecewise functions are grouping together more than one function, we have this curly brace to group them all together. So we're grouping 3 different functions together. That's why we have this right here. So what goes in our first spot are all the y values from our table. So I'm just going to insert all 3 of these y values into our function notation. So we always write the y values first, okay, which since these are just numbers, there aren't any variables. Whenever you just see numbers in a function, that is going to make a horizontal line. Okay, so this function has all y values at 8. This function has all y values at 6. This function has all y values at 5. So if you ever see just a lonely number in your function notation without any variables, your graph is going to have a horizontal line. And it's a horizontal line where it would intersect the y-axis. If you were to keep extending this, like this would intersect with y. If you kept extending this, this would intersect the y-axis at 6. You kept extending this, it would intersect the y-axis at 8. So that part's the easy part. Now the trickier part are x values, which are the intervals that each of these graphs occur on. So the x intervals that each of these occur on. So these are associated with the intervals from our table. Now, we can't just put these on there because we like to be a little bit more specific when we write using math notation. So there are 2 ways we're going to be writing these intervals, which you kind of get to decide which notation you prefer. I'll tell you the one that's you're most likely going to see with piecewise functions, but again, you get to pick because they mean the same exact thing. So for the very first one now, let's talk about interval notation. First of all, in the very first spot, you're going to write your smallest x value. In the second spot, you're going to write your largest x value. Now, before we get into more details on that, sometimes you'll see a closed bracket or just a bracket. Sometimes you'll see a parenthesis. Now, the difference between the two, if you ever see a bracket in interval notation, it means the graph can equal that value. If you see a parenthesis, that means the graph cannot equal that value. So usually when we see that, we're going to see an open bubble. Now, it is okay for your interval notation, this is called interval notation, it is okay for you to have two brackets or two parentheses, but in this case we're going to have one bracket and one parenthesis, which I know looks a little weird, but it's okay. We're good with weird. So, the reason why we have a bracket at 0, because if you look at our graph, at 0 in our first interval, there's a closed bubble. So that's why we have a bracket. Okay, and that is our smallest x value in our interval. Now, the reason why I did not write 1.99, the graph gets really close to 2, but it cannot equal 2. Okay, so all we're going to say 2 with a parenthesis, because that means it gets really close to 2, but it cannot equal it. So the parentheses means it does not equal it. So that is a more precise way to write this. Because technically 1.99999 is acceptable. Okay, so we're going to put a parenthesis as a bracket. Now, there's another way to write this notation, which this is the one you're most likely to see when you have piecewise functions. Now, interval notation is good to practice because this will pop up in future sections. But with piecewise functions, the notation you're most likely to see is called inequality notation. So we have interval notation and inequality notation. So whenever you have inequality notation, in this case, since we're dealing with x values, you're going to see an x in here. If we were dealing with intervals on the y, you would see a y in your inequality, but we're not. So we have an x, and this is saying the smallest x value is 0. And this symbol means greater than or equal to. Now, the reason why it's equal to is because we have a closed bubble at our 0 right here. So when x is 0, there's a closed bubble, so it can equal it. So x is greater than 0, but it has to be less than 2. Since the inequality is facing away from the x, it means it's smaller than the 2. And the reason why we don't have a line underneath our inequality is because it cannot equal 2 because of our open bubble. So you can pick to use either this notation, the interval notation, or inequality notation. But whichever one you pick, you have to use for all of these cases. You can't mix and match. So our next one, I said it went from 2 to 5 because if we look at our table, our start value is 2, which on our second graph, the 2 can equal it because there's a closed bubble. And the largest value goes to is 5 on our x, because it's in between the 4 and the 6, but it cannot equal the 5 because there's an open bubble right there. So that's why we have a parenthesis. Okay, so our smallest value again goes on the left-hand side, and our largest value goes in the right-hand side. And we use brackets when it can equal the value, and parentheses when it cannot equal the value. Or if you want to use inequality notation, x falls in between the values of 2 and 5. So x is larger than 2, and it can equal 2 because, again, of our closed bubble. Okay, so it can equal to 2, and it's larger than 2, and it goes from 2 all the way to 5, and it cannot equal 5 because there's an open bubble. So we say less than 5, but not equal to 5. And finally, our final notation, okay, for our final interval right here. Okay, so this one, we have a bracket on 5 because our smallest value is 5, and it can equal it because there is a closed bubble. And our largest value, so since we have an arrow, that means it extends on in the positive infinity direction forever. Now, I know this is a real life problem, so usually in real life problems, we do have a cutoff. But we're just going to say to infinity because the retailer did not tell us how far they would go. Hey, and whenever you guys use infinity in interval notation, you need to specify whether it's heading in the positive infinity direction, so to infinity and beyond with Buzz Lightyear, okay, or it could extend the opposite direction, which would be headed toward the negative x values, which that would be negative infinity, but we don't like to talk about negative infinity if we don't have to, because that's where the demon cats hang out. So let's move on from that. Okay, and whenever we're at infinity, since you can't really ever equal infinity, okay, whenever you use infinity in interval notation, you always put a parenthesis. Always. Okay, so anytime, it doesn't matter. I know that all these start with a bracket and end with a parenthesis, but that's not always the case, so be careful. So If you ever see an infinity in interval notation, you're going to be putting a parenthesis. Or, now this is different, since we have a start value but not an end value in our third function. Okay, we're not going to have a start and an end value like these two have. Okay, it starts at 5, which I know you guys can't see that. It starts at 5, which can equal 5 because it's a closed bubble. But it's everything larger than 5. We don't have a cutoff. So that's why we don't have an upper bound on our inequality. So this is x is greater than or equal to 5. So again, you either use all three of these or all three of these. You cannot mix and match, so be careful. Okay? And also make sure whenever you have more than one inequality, they must face the same direction. They do not get along. They don't want to face each other. So don't ever write like this one the opposite way. If you ever have more than one inequality, they should always face the same direction if you put them in one line. All right, so let's move on. That was fun times, you guys. So this one you guys are going to tackle when we do the fun seats together. So not yet. So this one will be a fun time, so you'll have to wait. Now, this next example, example 2, will be on evaluating piecewise functions. So we're going to be putting in different values for x within a piecewise function. So for this function right here, there's going to be 3 different x values that you're going to be inserting into this lovely function, which at this point you want to pause the video because we'll talk about how to insert separate values of x's into a piecewise function, as well as this one's a doozy down here. We're going to be combining several different function notations into one problem. So go ahead and pause the video and you can tackle part A and B of tackle 2, or example 2. Now, example 3 is going to be very similar to example 2. This one just has some harder functions in here. So again, this one I will be doing on a separate video. So you need to go and pause this Prezi and watch example 3, and you can tackle part A and B of this wonderful problem. Oops. Alright, example 4. Now this time we're going to step it up a notch because I don't think those last ones were hard enough yet. So now we're going to take it a step further and actually graph the entire piecewise function. So you're going to see all the values that work with the piecewise function instead of just focusing on individual values like we did in these previous problems. So on this one, to see how to do this, go ahead and click pause on this Prezi and watch the next video. Now, this one, example 5, it's similar to the last one. We will be graphing these functions, which these are a little bit more challenging functions to graph. Okay, and then you'll be graphing the piecewise function, and so there's a second phase to it, stating the domain and range. So we'll talk about domain and range in just a moment. So go ahead and click pause on the Prezi and watch example 5. Now, if you are still watching the video after completing 5, there is one more example problem that you will not see on the Prezi, but it will be a word problem, which you will need to watch example 6, which is the word problem, on the video that associates with it. So we're going to be combining everything that we've been talking about into a word problem. So it's going to be fun times. You're going to graph, you're going to find function notation, and you're going to learn how to interpret a word problem. So have fun, you guys. It's been a blast.